For this section 5.4, we're looking at medians and altitudes. So let's start off with looking at the median of a triangle. And the median of a triangle is the segment from a vertex to the midpoint of the opposite side. So it requires us to find a midpoint. So if we look down at our triangle here, we have LP. LP, we're going to give it a midpoint. And then the line from that midpoint to N is the median. If I look at LN, I can get another midpoint. And then the line from that midpoint to P, its opposite vertex, is also a median. And then finally, L will go to the median on NP to give us 3 medians. And there's 3 in every triangle. Now, the 3 of them will meet. They have a point of concurrency, and we call it here the centroid. So, when the 3 medians meet, the name for that will be the centroid. Now, we have a theorem to go with that. So the concurrency of medians of a triangle, or really concurrency, we're talking about the centroid. That says the medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So let's reword that and get it to fit a little better for us. So we start off with the medians of triangle ABC intersect at centroid P. So we know they intersect. That's the point they have in common. That's point P. Now, they're 2/3 the distance from each vertex. So the distance from here to A, from P to A, is 2/3 of the distance from A to E. So let's write AP equals 2/3 AE. BP is 2/3 of BF. Lastly, CP is 2/3 of CD.
Please report to the front of the school to wait for your ride.
Let's try that again without the announcement. CP is 2/3 of CD. So that exists in all of them, but that 2/3, we don't like that. So let's take a look actually at this part again. So we're just going to take that out, and we have A goes to E, and P is right there. So we said that A to P is 2/3 of the whole thing. So let's call that a 2/3. Well, if that's 2/3, that means to get to the whole thing, from P to E, there's really just 1/3 left over, and that gets us the whole thing. This is an important ratio that's really going to help us, because yeah, we do get 2/3 AE equals AP, but that gets stuck. If we can remember this ratio, though, it starts to give us something to work with. And we can see why. First of all, these two things need to add up to be the whole. That goes back to segment addition. That's a basic concept we should already have. But if I know this piece, that 1/3, and I want the other piece to go with it, well, to get 1/3 to 2/3, I'd have to double it. So I double that value. Conversely, if this is 2/3 and I want the 1/3, I would take half of it. Also, if I knew the whole thing and I wanted the shortest piece, I would take 1, divide it by 3 to get the 1/3. So let's even look at some values here. So we're just going to take this idea of looking at AE with its centroid and just to start seeing how the values work. So I got a few examples here. And if we can just understand where the values fit, we'll start to see how it all works together. So remember, we have A, P, and E. It's our 2/3, 1/3. So let's say, and they were just applying this to all of them and just do some quick examples with them. So let's say I know that this segment is 3. That's my 1/3. So I'm here, and I want the next piece. Well, I double that to get this segment. So that's 6. Twice 3 is 6. That's the other part. We add those together. It gives us a total of 9. Look at another one. Now let's say I have the longer segment. That's 4. Okay, well if I want the 4 and I'm at this area, to go here I need to take half. If I'm at 2/3, I want 1/3, so I'm going to take half of that, which is 2. Add those together, gives me a total of 6. If we look what we have so far, I mentioned earlier that if we had a 9 and we had our longest side, which is 9 in this case, divided by 3, it would give us our shortest, 3. 6 divided by 3 gives us our shortest, 2. So we can see the values start to work together. Well, let's try one where we say, all right, the whole thing is now 15. Which parts are you going to have? I just said I can divide 15 by 3 and get the smallest part. Well, 15 by 3 gives me 5, and so my other part would have to be 10. We have to be careful, though, to make sure we put it in the right place. I have this segment, and I have this one. Now, just thinking, looking at this segment, it's a shorter segment, almost half the length of that segment. Look at it, find the longer one. The distance from the centroid to the vertex is always the longer one. But we forget that at times. So let's just think, which one's longer, which one's twice the other. This one needs to be 10, this one should be 5, it's double the other, and they add up to 15. Last one, let's say we have 24. Sometimes we want to just look at 24 and go, 24 must be 6. We have to be careful, make sure we're still dividing by 3, because even if we wrote 6 there, and then we doubled it and made 12, well, 6 and 12 don't add up to 24. We don't want that one. So 6, or 24 divided by 3 is 8. Double that, 16, and we get our value there. So hopefully you start to see the pattern. We double the smallest one to get the other segment. We add them together to get the whole thing. We can divide the whole thing by 3 and get the shorter segment. This is going to exist in all centroids. Anytime we have the median, this is what we're going to use. If we need to find a side, this is the idea we want. Now, keep in mind here, let's jump back up to this top left one. I ignored 2 other lines, but if I look at this highlighted one, if they told me some value on this segment, and I'm still looking for, say, 6 here, I'm still working through that, any value on here has nothing to do with the line we were focusing on, AE in this case. That, it's on its own segment, it's going to have its own 2/3 to 1/3 relationship. We need to keep it separate. So make sure we don't jump and start mixing them up. Now, we sketch out some centroids here. We're just looking at midpoints, looking for approximates. First, I have an obtuse triangle, looking at its finding midpoints, connecting them. Now, just by drawing 2 of them, I already have them meeting at a point. That third one will automatically have to go through the third point. So really, anytime we're looking at medians, or centroids for that matter, if you have 2 medians, the third one is going to go through that point as well. We have ourselves an acute triangle. They meet at our point, our centroid, and finally our right triangle. Our 3 points, or our 3 lines meet at our point, our centroid. Notice in all of them that that point, that centroid, is inside the triangle. The one we're going to look at a little bit later, altitudes, does not necessarily have to be there, but it's inside the triangle. Okay, quick example. If you're doing this on your own as you follow along, maybe it's a good time to pause to try this one on your own. But we have SQ is 8. We need to find QW, SW. So I have my 8 here. I'm looking at this segment. If SQ is 8, I need this other piece. Well, we've already said we have the 1/3, 2/3 relationship. So I'm either going to take half or double this 8 to get the other part. Well, looking at it, this 8 in SQ, that looks bigger than QW. So this gives us the idea, maybe we do need to take half, and in fact we do. So that's 4 for QW. That means SW.
All staff, please remember to post your attendance. Thank you.
That means SW will need to be 12 because that's the total for the 2. And again, like I mentioned a little bit earlier, if I knew something on UT or VR, I cannot use those because it